Hello everyone, welcome back to another video. So today what I have decided is we'll try to solve this daily challenge in front of you. Means I will solve it and also record myself, and so basically it will help you understand my approach and how I solved it. I never took this daily challenge seriously. I barely solved them, but uh, a lot of people solve this to maintain consistency. So I thought let's just make videos of these daily challenges. So what I will do is I will open this question for the first time right now and solve it as fast as I can, and then I will parallelly explain my approach, and at the end I will explain the editorial for this. So let's just open this question. So we are given a string s and integer k, okay, and we call a string t ideal if the following conditions are satisfied. Subsequence, okay, and absolute difference between alphabet order of ev every two adjacent letters in t is less than or equal to k. So subsequence, okay, so return the length of longest ideal string. A subsequence is a string that can be derived from another string by deleting some or no characters without changing the order of the remaining characters. Okay, so alphabet order is also not cyclic. So in this question, you see ACFG. The ideal string can be ACBD, okay, because AC difference is 2, BC difference is 1, and DB difference is 2. So it is less than equal to k. Now in the whole string cannot be ideal because C and F has a difference 3, and in this case the whole string ABCD itself. So first, reading this problem itself, we can have an idea like TP, because we are asked a subsequence, and subsequence can be to take the current element in the subsequence or not. And for that condition of checking k, I have only 26 possible options, right? Because there are 26 characters. So let's just try to code my solution. Yeah, int previous to dot length. Previous of s of 0 equal to, we have initialized dp for the first character itself, and it will be 1 because I think at every position there should be 1, because the substring, what I can, the subsequence of length 1 always satisfies our condition. To 1 I less than n I plus plus. So for each I, the previous element of uh, previous character can be anything between A to Z. So First of all, let me declare a current answer till this subsequence as 1, because 1 itself, the subsequence of length 1 is itself an answer. Then what I'll do, character c equal to a, c less than equal to c plus plus. Now in the previous map I will store probably the max subsequent max length of subsequence of each character till now. So if first of all absolute difference between c and current character s of y is less than equal to k, dot find c not equal to previous dot end. What I will do is take answer max with current element plus previous of c, and I will also store the current answer in previous of s of y, and also update the dp. My answer it reads equal to 1. I will take max of res comma answer. Let's see if it works or not. The logic seems pretty correct to me, so it got accepted. And how I approached this question, so first of all, reading this description I understand that this was a linear DP type solution. Now in DP what is important is number of unique recursive calls if you are solving it with recursion. Now number of recursive calls here can be that I am at ith position, and maximum answer of all characters from A to Z which are ending at character A to Z means maximum subsequence length which are ending at character C from character A to Z. I have stored them, so that character can be anything from A to Z. So maximum number of unique recursive calls can be n into 26. So if you want to write this recursively solution, you can also write that, but I was able to understand those transitions, and so let me just explain it in more better way. So let's say I have a string of length n. This is 0, this is 1, this is 2, and so for the first dp vector, for first element, it will be filled with 1 itself, because we are initializing the part, and the first character can itself make only if the what let me just explain this, what dp of I represents. So dpi of I represents maximum length of maximum subsequence length which is ending at uh, which ends at ith position. So for first character, there is only one possible way, which is that character itself. Now for second character, what are the possible combinations? First combination is make a subsequence with first character and second character, or make it, itself as a start from that character itself. Now there is a required condition for a subsequence which contains zeroth character and first character, that is the absolute difference between any two adjacent letters must be less than equal to k. Now if this is b, and this can be anything from a to z, so I have to check the condition for this. Now you will also argue that if I am at this position, let's say something like m, I have to check all these characters which are before this, so m minus 1. So number of possible combinations here, where I am taking each character from 0 to m minus 1 for mth character, and taking the maximum of dp of j plus 1 if condition satisfied, where dp of j is from 0 to m minus 1. But that is not necessary, because in m minus 1 there will be a lot of collisions where I have same character at two positions. For example, in this case, let's say I have this is, let's call it as j1 and j2. There is a character twice. Now I don't need to iterate both of them. I need to only iterate at max of them, max of uh, the element which gives dp of j1 max. That means the previous element, if there are two indexes where previous element of m, means in subsequence, let's we are considering the subsequence which ends at mth index. So previous element can be anything from a to z. Now for if we are checking all the possible combinations for a, we don't need to check all possible combinations. We only need to check such index which gives maximum of dp of j, or we can say maximum of subsequent length at which j index ends. So this type of solution works, and the complexity here comes out to be n into 26, and also the for storing map of 26, again 26 log, and you can consider that, but it will be not an issue. So what I did here is I declared all the things and created a map of called as previous, and previous basically stores maximum subsequence length of ending at every character from a to z. And then what I'm doing is iterating over each character and finding the previous of c, means previous of character c, if the condition is satisfied, and I'm taking max of it, storing it in previous of s of I, because for s of I one of the answer can be this answer which I calculated, but I have to take maximum of it. And you can also argue that there will be uh, always new answer which comes for s of I will be always maximum, but you don't need to consider that. You can just take max of both of them, don't need to worry that such for such conditions. And then finally I'm storing that dp of I in answer and taking max of current answer. and finally returning the answer. Now this solution might be rusty. I am using a lot of variables, but if it works, it works. And if you understand the logic, I will try to upload this video. As you can see, I also solved first kind of. I'm started the streak today, so I will try to make as many videos as possible. It will be in early morning, so as I'm recording at 8 a.m. right now, so probably tomorrow also I will record at the same time. So yeah, thanks for watching.